There are four types of electron displacement. They are inductive effect, electromeric effect, mesomeric effect or resonance effect, and hyperconjugation effect. The overall polarity, whatever it is produced in an unsaturated system, that is pi bond system, there the complete transfer of electrons to the bonded atom will be happen. Groups or atoms which decrease electron density, obviously it will decrease the electron density in the ring system, are known as electron deactivating group. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today we shall start up the session 5 from the chapter Organic Chemistry, some basic principles and techniques. In the last class we have seen isomerism, the definition of isomerism, types of isomerism, and fundamental concepts in organic reaction mechanism like homolytic cleavage, heterolytic cleavage, what are the kinds of products will be seen in the different types of cleavages we have seen in the last session. So, in this session we will see electron displacement effects in covalent bonds and types of organic reaction. These are the two contents we will see in this session. First we will see electron displacement effects in covalent bonds. The displacement of electrons in a covalent bond takes place either by influence of atom or group of atoms present in the molecule or by the influence of attacking reagent. As a result, carbon chain gets polarized. Here, by a displacement of electrons means one place to another place or position of electrons will be changed in a covalent bond either by influence of atom or a group of atom present in a molecule, whether the molecule inside the molecule only displacement will take place or by the influence of attacking reagent the position of electrons will be changed. Anyhow, as a result the chain or the carbon chain gets completely polarized. Polarized means charge separation will be taken place. There are four types of electron displacement. They are inductive effect, electromeric effect, mesomeric effect or resonance effect, and hyperconjugation effect. These are the four electron displacement effects. First, we will see inductive effect. The permanent polarity produced in a carbon chain due to the partial displacement of sigma bond pair of electrons towards more electronegative atom or group. Here, permanent polarity will be taken place in the carbon chain. Permanent polarity means once again that it will not be reversible, and whatever the polarity will taken place, polarity means once again I am telling it's a charge separation, whatever it will take place in the carbon chain it won't be reversible, and whatever the partial displacement of sigma bond pair will take place, it will be towards more electronegative atom or group. Whatever the charge separation will take place inside the carbon chain, it will be going towards the more electronegative atom. That's why the partial displacement of sigma bond pair will take place. See here, this is methyl and this is, if the sigma bond pair has been displaced, CH2 is electropositive, this is chlorine is electronegative, halogen this is more electronegative, that's why the sigma bond pair will be moving towards the more electronegative atom. In that minus I effect is there and plus I effect is there. We will see first minus I effect. If an atom or group attached to the carbon chain is more electronegative than carbon, then the carbon chain acquires a partial positive charge. This is known as minus I effect. Whatever the atom or group attached to the carbon, if it is more electronegative than this carbon, all the partial charges will move towards the more electronegative atom. That is what minus I effect. Atoms or groups which cause minus I effect are termed as electron withdrawing groups. That will be EWG, means whatever the elements, whatever the atoms or groups which will cause the minus I effect. What is minus I effect? The atom which is surrounded by the carbon is more electronegative than the carbon will cause minus I effect. So, it will be called as or termed as electron withdrawing group. It will withdraws the electron. Order of atoms and groups which causes minus I effect is, this is nitro, cyano, carboxylic acid, fluoro, chloro, bromine, iodo, ether and benzyl group. These are the order of atoms or groups which will cause minus I effect. From nitro is more, here benzyl is least. Next is plus I effect. If an atom or group attached to the carbon chain is less electronegative than carbon, then the carbon chain acquires partial negative charge. This is known as plus I effect. Here, whatever the atom or group attached to the carbon, it will be less electronegative than carbon, so it will attain delta plus charge, means it will attain partial negative charge. Okay, it will acquire partial positive negative charge. And atoms or groups which cause plus I effect are termed as electron releasing or electron repelling groups. So whatever we are giving, that electron releasing or electron repelling groups we will call. Alkyl groups like methyl and ethyl are considered as electron repelling groups, means it will release the electrons towards the carbon, or electron donating groups also we can say. Order of atoms and groups which causes plus I effect is, see here, this is tertiary, this is secondary and this is primary. And methyl, from the tertiary carbocation to methyl, the order will be in the decreasing order. The important features of overall inductive effect is, it is a permanent polarity effect and it operates in a saturated and unsaturated system. Saturated means single bond system and unsaturated means it may be double or triple bond system. Partial charges are produced in plus I, minus I effect. Positive charges will be there and negative charges will be produced in the overall inductive effect. Influence up to third carbon in the chain. Strength of the effect decreases with increase in distance from the group attached to the carbon chain. Whatever the strength of the effect is there, it will be decreased with increase in the distance from the group attached to the carbon chain. This is about the important features of inductive effect. Next one is electromeric effect. The polarity produced in an unsaturated system. Unsaturated means pi bond system. In the presence of an attacking reagent, known as electromeric effect. It involves complete transfer of pi electrons to one of the bonded atom. Okay. What they are telling? The overall polarity, whatever it is produced in an unsaturated system, that is pi bond system, there the complete transfer of electrons to the bonded atom will be happen. In that, plus I effect is also there, minus E effect is also there. So, if the migration of pi electrons and the attack of the reagent is towards the same atom, the effect is known as plus E effect. That is, pi electrons are transferred to the site of attack. See here, this pi electrons is moving towards the atom and it will be deficient and it will be attacking here. Okay. Minus E effect. If the migration of pi electron and the attack of the reagent is towards the different atom, then the effect is known as minus E effect. That is, pi electrons are transferred away from the site of attack. Means it is nucleophile. In that case, it will be electrophile. Nucleophile means electron rich and it will be donating towards the unsaturated system. See, nucleophile, it is donating here and from here it is donating to the carbon, right? So, attacking will be there and here minus E effect will be seen in this electromeric effect. Next, important features of electromeric effect. Temporary effect, that is, this effect will vanishes as soon as the attacking reagent is removed. Means, whatever the nucleophile is added, then the electron donating will be happen. Whenever the electrophile will be added, that time the electron attracting will be happen. Means, whenever the reagent is used, that time this effect will be there. Whenever the reagent is removed, that time the complete effect will be vanished out. That's why we'll call it as temporary effect. And unit charges are produced. Unit charges, however, it will produce. operates between two atoms bonded by a bond, that is operates at a short distance. In the inductive effect, till the third carbon it will happen, but here within a short distance it will happen between the two atoms bonded, then only this effect will work. Operates only in a pi electron system. Pi electron system means wherever the double bond is present, means unsaturated system is present. Approach of electrophile results in plus E and approach of nucleophile results in minus E effect. And pi electrons always migrate towards the more electronegative atom. Yes, wherever the more electronegative atom is present, there only the pi electrons will be migrate. This pi bond, see here electrons, pi electrons will be moving towards electronegative, that is oxygen is more electronegative. Here also it will be added, okay, means electron rich will be there. Next is resonance effect. Before the resonance effect, you have to understand what is resonance, why we will using resonance, everything. The phenomenon in which a compound is represented by two or more structures is known as resonance. Okay, a compound, whatever the compound, it will be written in a two or more methods. That kind of structures will be called as resonance. The different structures of the same compound are known as a canonical forms. Means if benzene we write here in a three forms, that three forms, individual forms will be called as canonical forms, and the actual structure is the resonance hybrid of various canonical structures. Okay, resonance structures are not actual structures and do not represent any real molecule. Whatever the resonance structure or canonical forms we will write, it will not completely as actual structure. By this resonance structures, various kinds of resonance structure, the hybrid will be the one form of a resonance structure, the hybrid. The resonance hybrid is less energetic and more stable than any one of the canonical form. Yes, by the canonical forms, one resonance structure has been formed. That's why it will be less energetic and more stable rather than the canonical forms. Resonance increases the stability of a molecule and decreases its reactivity. Whenever the resonance structure has been formed, that time it will increases the stability of a molecule. The stability of molecule is increasing means obviously the reactivity will be decreased. The energy difference between the actual structure and lowest energy resonance structure is called the resonance stabilization energy or simply resonance energy. The difference between the actual structure and the resonance structure will be called as resonance stabilization energy and the resonance energy. Okay, this is about the complete introduction part of resonance and rules for writing resonance structures. How you have to write the different kinds of canonical forms. Resonance structures must have the same positions of nuclei and the same number of unpaired electrons. Before writing or after writing, the structure should resemble the number of unpaired electrons and the position of nuclei should be same. Among the resonance structures, the structure with more number of covalent bonds, all the atoms with octet of electrons except hydrogen, less separation of opposite charges, a negative charge on more electronegative atom and a positive charge on more electropositive atom, and more dispersal of charges is more stable than the other structures. Here, whatever the less separation of opposite charges they are telling, a negative charge will be present on more electronegative atom and the positive charge will be present on more electropositive atom. Means a more dispersal of charges is more stable than the other structures. Whenever the charge separation is taken place, that structure will be more stable than the other structures. What is the need for resonance? For many organic compounds, a single structure does not explain all the properties of the molecule. Means if we write a benzene or any kind of compound in a one structure, the bond angle will be same. By that bond angle, melting point or boiling point will be comparative to that structure. If we change the little bit structural order, obviously the melting point or the boiling point, the bond angle, all the physical properties or all the chemical properties will be changed. So, by writing the different kinds of structures, the properties of the compound will be changed. By that we can study more than one concept. In such cases, a hypothetical structure which could explain all the properties of compound is written and is known as resonance structures. Here example, benzene. See, here double bond is present and alternative double bonds are present. See the position of double bonds. Here it is a opposite side and those two structures will be called as canonical forms and the overall hybrid will be called as resonance hybrid. We can write benzene like this also and both this also. When you are writing the resonance or electron movement in the reaction mechanism, obviously you have to write in this of the either of the way. But when you can write the complete reaction in a substitution or anything, you can use this benzene. Kekulé structures or resonating structure. Kekulé is a scientist who discovered the benzene. That's why his Kekulé structures also we can tell. This structure of benzene has 3 carbon and 3 carbon-carbon bond. But experimentally it is observed that all the carbon-carbon bonds in benzene are same length. Yes, all the carbon bonds are in the same length and this could be explained using the above structure. Okay. Next is resonance effect or mesomeric effect. The polarity produced in a conjugated system as a result of interaction between 2 pi bonds or a pi bond and a lone pair of electrons is known as mesomeric effect. It involves the transfer of pi electrons or lone pair of electrons to the adjacent sigma bond. Means here also charge separation will take place obviously, but in a conjugated system. Conjugated system means, see here, this is a double bond, means the alternative double bonds will be present. Here is also a bond, but no double bond will be present. This is a conjugated system. As a result of interaction between 2 pi bonds and a pi bond, a lone pair, whatever the effect will be produced in the conjugated system will be called as the resonance effect. It involves transfer of electrons, pi electrons or a lone pair of electrons to the adjacent system. This is adjacent means the transfer will be takes place. So, resonance effect is of 2 types, plus M or plus R effect. The migration of pi electrons or lone pair of electrons away from the group attached to the conjugated system is known as plus M. Such groups atoms are termed as electron releasing groups or atoms. Away from the conjugated system means electron releasing group. See here, the lone pair are getting to adjacent and if it is added here, the double bond will turn to here and it will become positive and it will become negative. Means the more electron rich is present, automatically a cyclic nature will takes place obviously. Okay. A rotation of bonds to adjacent sigma bonds will take place. This is pi, right? See here, this is pi. This is sigma. It is going to converted into or transferred into a sigma bond. And consequences of plus M effect. Groups or atoms which increase electron density in the ring system and facilitate the electrophilic substitution reaction. Okay. Electrophilic substitution reaction should be facilitated are known as ring activating groups. These groups are direct the incoming electrophile to ortho and para position. So, ortho-para directing groups will be called. Okay. That will be example chloro, bromo, iodo, amino and hydroxy, alkoxy will be called. Next is minus M. The migration of pi electrons or lone pair of electrons towards the group means towards the group will be done, not from away the group. To the conjugated system is known as minus M. It will be called as electron withdrawing groups. Okay. Groups or atoms which decrease electron density, obviously it will decrease the electron density in the ring system are known as electron deactivating group. Whichever it is getting, that will be electron activating, which will be releasing or decrease the electron density, that will be called as deactivating groups. These groups or atoms which direct the incoming groups for meta position are called meta-directing groups. Plus M, it will be ortho or para-directing groups. In the minus M, it will be meta-directing groups. That is nitro, cyano, ketone and carboxylic and aldehyde. Next is hyperconjugation effect. It can be also called as Baker-Nathan effect or no bond resonance will be called. The delocalization of sigma electrons of CH bond of an alkyl group directly attached to an unsaturated carbon atom or an atom with an unshared p orbital is known as hyperconjugation. Hyperconjugation increases the stability of the species. Okay, see here. Example, ethyl carbocation has 3 hyperconjugative structures. See, first point, these are all sigma electrons. Whatever the sigma bonds are present, those are all sigma electrons are there, single bonded, and all are moving to the directly attached to the unsaturated system, and it is forming the unsaturated system. See here. Okay, that will be called as hyperconjugation. See, all are first saturated system and moving towards the unsaturated system, and it has 3 hyperconjugative structures. Here getting, and this hydrogen is moving out, and see, if this is moving out, then 1 hydrogen, and this is moving out 3 hydrogen. So 3 ways are present. More the number of alkyl groups attached to the positively charged carbon atom, more the number of hyperconjugative structures and higher the stability of the ion. See, here CH is there, 3CH3 is there. That's why the stability is more and the hyperconjugative structure is more. Here only 2 lesser than this one, only 1 lesser than this one. This is only methyl. So for the methyl group, how many alkyl group is getting to attach? It will increase the hyperconjugative structures. Obviously, stability will be more. So order of stability of methyl, primary, secondary and tertiary carbocation is explained on the basis of plus I and hyperconjugation. See, carbocation is more stable than this. Tertiary carbocation is more stable than secondary because more hyperconjugative structures are there, and here less hyperconjugative structures are there. Next is types of organic reactions and mechanism. Organic reactions can be classified into 4 types as follows, that is substitution or displacement reaction, addition reaction, and elimination reaction and rearrangement reaction. We'll see one by one. What is substitution or displacement reaction? One molecule will be attacked by another molecule, that new compound will be formed. In a substitution reaction, an atom or group present in the substrate is replaced by another atom or group. It will be replaced. That is chloroethane, a base. So this OH will be replaced here and Cl will be displaced. So it will form methanol. And addition reaction. In an addition reaction, atoms or groups are added to the unsaturated system. Addition means, see, this is unsaturated system. Here H2, hydrogens are added. See here, CH2 will form. And next is elimination reaction. In elimination reaction, 2 atoms or groups are removed from the same adjacent carbon atom. See, chloromethane, by the addition of alcoholic KOH, it will form ethene. Here KCl will be removed and water molecule will be removed. And next is rearrangement reaction. In the rearrangement reaction, migration of an atom or group from one atom to another atom within a molecule will takes place. Okay, rearrangement only. This N-pentane will be formed 2-methyl-butane in the presence of anhydrous aluminium chloride. This is in a chain isomer. It will form a branched isomer like isobutane also we can tell. In the next class, we will see methods of purification of organic compounds, that is distillation, sublimation, crystallization, differential extraction and chromatography. I hope you have understood completely about the electron displacement effect and types of reaction whatever we have discussed today. So, we will meet in the next session. Thank you.